question like this, which is a proof question, can be quite intimidating sometimes. Often a student might prefer just to have some big formula that they can start taking derivatives of. But here we just have a brief little sentence, and often, you might not know what to do there. So let's see what this is all about. We want to use the chain rule and the product rule to give an alternate proof of the quotient rule for derivatives. So I think you remember what the quotient rule is, right? If I have two functions, f over g, and I want to take the derivative, first of all, this is definitely not equal to the derivative of the top over the derivative of the bottom, right? That's classic beginner mistake. We don't want to ever make that mistake. This derivative of this quotient is the derivative of the top times the bottom left alone minus the top left alone times the derivative of the bottom all over the bottom squared. So we want to derive this. We want to prove this somehow. Usually the way we do it, or the way we did it before, is using the definition of the derivative, limit as h goes to 0. But we want to derive this another way. Let's see how that goes. So our end goal is to prove this statement, but we want to prove that using the chain rule and the product rule. So the trick for this is like this. If we have a quotient of two functions, we can rewrite this as f of x multiplied by g of x to the power of -1, right? And now it's a product. And if we want to do the derivative of this, we could, using the product rule. So let's throw a derivative on there, take the prime of both. So the prime of this quotient is the same as the prime of this expression. This expression is just another way of writing this quotient. And now we can make some progress on that using the product rule. Let me go down here instead. So the product rule says this: I do the derivative of the first one times the second one left alone plus the first one left alone times the derivative of the second factor. So let's see what we get here. Writing f of x in brackets with the prime is just a long-winded way of writing f prime of x. These brackets really aren't necessary. I just put them there before for clarity. These brackets aren't necessary either. Now, how about this? This might be just a little bit confusing. It won't be too bad, though. We have something to the power of -1. So the thing we're ignoring right now is the g of x, okay? So it's like the -1 comes to the front. I'm ignoring g of x. The power goes down by 1. And then I multiply by the derivative of what I was ignoring. Namely, I multiply by g prime of x. I hope that step is okay. Now, we're kind of done. We just need to clean this up a little bit. Let's see what we have here. Let's get rid of this negative exponent by bringing the g of x to the bottom level. Actually, since we have a minus here, let me write a minus instead of a plus. On this level, we have f of x times g prime of x. And this g of x to the power of -2, I can get rid of the brackets and bring it down to the bottom level. So we are making good progress here, believe it or not. Let's get a common denominator. We have g of x squared here and just g of x here. So we would like a common denominator of g of x squared. Let's multiply top and bottom of this by g of x. We certainly can do that. And g of x times g of x is g of x squared. And this one I'll just recopy as it is. And we are very close now because we can write this as a single fraction now, right? The bottom is just g of x squared, the common denominator. And the top is f prime times g minus f times g prime. And this is the quotient rule. We're done. So we've just proven the quotient rule using the chain rule and the product rule.